Hello again. Previously, we built an atom. Today, we're going to try and build a molecule today. Let's start with the PHET simulations and let's see what we've got. Okay, there we go. It's loaded. First, we're going to start making single molecules. What's a molecule? It's a combination of more than one atom. It could be of one type or more than one type, right? So hydrogen is the first element in the periodic table. We're going to take two of these and let's see if they make up a molecule. And yes, they do. Let's take oxygen and let's review this. This is the hydrogen molecule, right? In the form of a bond, it has a single bond, right? Now, hydrogen is actually a diatomic molecule. That means it has two atoms making up the molecule. What is a molecule? It's a combination of more than one atoms, right? In this case, we have both atoms of the same element, which is hydrogen. So this is H2. It's a gas. Over here, we can see how they would be physically bonded together in the form of atoms, right? So let's start over again and let's take one hydrogen and one oxygen. Let's see if these form something. Oh, this does. Makes water, right? So when two hydrogen atoms combine with one oxygen atom, oxygen is also an element from the periodic table, so it makes water, right? So there we go. Let's have a 3D look at this molecule. This is how one oxygen atom is bonded with two hydrogen atoms, right? If we look at the bonds, we would find two independent bonds since oxygen requires two electrons to complete its octet rule, so it will share one electron each from each of these hydrogen atoms, making two single individual bonds with two hydrogen atoms, making a water molecule, right? Okay, so this is what we have in terms of these molecules, right? So let's take now two of the oxygen molecules and let's join them together. Let's see what it makes. It makes oxygen gas, right? Let's have a view at this. Now, as we know, oxygen requires two electrons to fill its outer shell to become stable. Over here, since we have only oxygen atoms to make bond with, so each oxygen is sharing two electrons to form a double bond. So as you can see now, there are two bonds between these two oxygen atoms. So in 3D, it will look something like this, right? Just like oxygen, just like hydrogen molecule. So it's also a diatomic molecule with these two bonds, except with hydrogen it was a single bond. Over here we have a double bond, right? So this is oxygen. Now let's move to nitrogen. Now if we have nitrogen, as we know, nitrogen is the seventh element and it requires three electrons to fill its outermost shell. So let's have a look at it. So it would form three bonds between two of these atoms. Each atom is participating with three of these outermost electrons to fill their valence shells, which is again to follow the octet rule. So again, in the form of a molecule, it's still a diatomic molecule of a gas, two atoms of the similar type forming up a molecule. But in terms of the bond, we can see clearly there are three independent bonds, or 3 points where the electrons are being shared, 3 electrons from each atom participating to form these triple bond, right? So we can also make other molecules like carbon dioxide, right? it's also a gas. So if you look at, oh, I just reset that. Let me get it back. Yeah, there we go. Now let's have a 3D view. Now we know that oxygen makes a double bond, and carbon, on the contrary, is in the fourth group, which is the metalloid group, right? And carbon requires 4 electrons to fill its outermost shell, so it will make a double bond with each of these oxygen atoms, where oxygen is sharing 2 electrons each, while carbon is sharing 4 of its outermost shell to form this uh, double bond, right, on each side, and forming a carbon dioxide molecule. In the form of a molecule, it will look something like this, where carbon is in the middle, and the double bonds made by these oxygen atoms, right? So this way you can make several of these compounds, including carbon monoxide. I think this is how it should look like, right? So oxygen is making 3 bonds with carbon, where carbon is sharing 2 of its bond, which we call as a coordinate covalent bond, right? Where one atom is actually sharing the whole pair itself, rather than sharing between 2 atoms. So carbon is giving 4 electrons to make the third bond, while oxygen is sharing just the 2 pairs. A pair of electrons. These 2 bonds are made by oxygen, while the third is entirely formed by carbon, giving its complete pair. In terms of the atoms, you can see this is how it's going to look: carbon monoxide. And since this carbon over here, we see an electronic disturbance, right, where oxygen is actually fulfilling its outermost shell, but carbon still requires extra electron to fill its outermost shell. So this is not a stable molecule, so it would try to react with oxygen as soon as possible. That is why carbon monoxide also burns when there's less oxygen in the air. When you're burning carbon, you get carbon monoxide. When you release this carbon monoxide into air, it's poisonous, as well as the fact that it also burns to react with oxygen. It's also an exothermic reaction, and it forms carbon dioxide eventually. So now we can try making other connections, right? Okay, I want to join one hydrogen. Okay, I cannot have this. Okay, that's all I can make. Carbon and nitrogen, right? Now again, this should be okay. Diazomo, diazomethane, methanol. Wow. Okay, that's a difficult name to pronounce. Okay, now this is a combination of carbon with nitrogen forming up these bonds. I think it's not stable actually, since carbon is having 4 bonds, so that's fine. Oxygen is having 2, that's fine. This nitrogen is having 4 over here, and this nitrogen is also having uh, 2, actually 2 of these. So this one is having 2, this one is having 4. One of this, yeah, must be a coordinate bond, right? Otherwise it would be very hard to fulfill. Let's say 1 2, yeah, 2. Okay, they cannot more than that, right? It's a coordinate bond over here by one nitrogen, which is like having the 4 bonds, so it's taking hold of the extra pair, so that this nitrogen atom would only make 2 bonds, right? So this one is on the contrary establishing 4 bonds by taking that extra pair from this nitrogen atom. That is what we call as the coordinate covalent bond. So now we can go to multiple atoms, right? Multiple molecules, and we can go to the playground where we can try and create something. And here we have 2 chlorine. Chlorine forms a single bond. It's a greenish gas. So let's say we can make HCl, yeah, which is an acid. So this is how the HCl is going to look like, right? Where actually the chlorine atom is quite large and hydrogen is very little. Okay, let's make hypochlorite. One oxygen, one chlorine. Now this is how the hypochlorite acid looks like. HCl, right? Having these bonds where oxygen is again making two bonds, chlorine is making one, hydrogen is making one. Hmm. Let's try making NH3, right? Ammonia. There we go. We have three. Yeah, this is ammonia, where one nitrogen is making three bonds with three hydrogen atoms, right? Okay, that's ammonia right there. Uh, hmm. Let's make nitric acid. HNO. Oh, no, yeah, we need more. Okay, HNO. Yeah, that's nitric acid, right? One double bond with nitrogen. Uh, red ones are the oxygen atoms, blue one is the nitrogen atom, white one is the hydrogen atom, so this is the nitric acid, right, molecule. Let's put it aside. Let's make this time around hydrogen cyanide, right? Okay, this doesn't work. Let's put it back. Carbon monoxide doesn't work. Formamide, that's actually an organic molecule. Currently we're working with inorganic ones, so let's not make that one. Okay, let's explore more. We have fluorine, fluorine, chlorine, so many. So you can make tons of molecules and see what you get. Hydrogen bromide, also an acid, right? We have uh, phosphorus, right? Mm, boron, sulfur, hydrogen. Let's put some hydrogen atoms to this. Borane is the molecule, right? Okay, so you can try this out. It's an amazing work. All you need to do is to just start with this single molecule C, start identifying, then study their three-dimensional structures, then go for multiple atoms where you can fill these goals. You need to make these molecules and place them in, right, just to finish that level, and then you can go to the playground and discover some fancy molecules. Just make some combinations and see if it works. If it gives you a three-dimensional image, that means that's actually an identified chemical. And then you can search that chemical on the internet and study about it, see the properties, basic properties, chemical properties of that chemical. For example, if you have hypochlorous acid, we can search this out on Google and see what are the basic properties. Same for ammonia, right? So any unused atom we should place it back before it becomes explosive. We don't know how the separator is going to react. Unlike physics, where you actually can burn, virtually burn stuff around. I don't know. I haven't checked this out if it does explode or not. Okay, thank you for your time. I hope the video would help you study these molecules and atom combinations and explore some chemicals. Thank you. Bye bye.